In this video, we're going to have a look at a question relating to mechanics and motion. So in this first part of the question, it's giving you a speed time graph. Bear in mind the time is given in minutes, so you do have to be careful of that. It's told you that the speed limit is 22 meters per second, and it's asked you to find whether the average speed has exceeded the limit. So average speed talks about the journey as a whole. So just in general, we know the speed is distance over time, and the average speed is the total distance that you've traveled divided by the total time taken to travel that distance. That will give you your average. How do we find the total distance from this graph here? Well, actually, if we rearrange this equation here, we get distance is speed multiplied by time. So if you find the area under this sort of graph that's formed, that will give you the distance traveled by the car. So let's do that. The best way to find the area is to split it up into three separate shapes. So we have a trapezium, a rectangle, and a trapezium. Just a reminder, for the area of a trapezium, it's a half a plus b multiplied by height, where a plus b are the top and bottom lengths, or these two lengths. And the height is the vertical height from the top to the bottom of the trapezium. Great. So this here is 15. This speed here reaches 24. That's the same here because it's a rectangle. And yeah, that's a speed of 12. We can now find the area of this trapezium. Let's call this area 1. Area 1 is found by doing a half of a plus b, 15 plus 24, all multiplied by the height of the trapezium, which is 1.5 minutes. But bear in mind, the time is given in seconds here because we want the speed to be in meters per second. So 1.5 multiplied by 60 converts that into seconds, that's 90. If you multiply all this together on your calculator, you'll get a value of 1755. Let's write that out. And let's now look at finding the area of this triangle. So that's just 24 multiplied by the minutes, which we have to convert to seconds as well. So 1.5 to 2.5 is 60 seconds. 60 times 24 is just 1440. And then using a similar method for the area of this trapezium, it's a half of 24 plus 12, all multiplied by the vertical height. 2.5 to 4 minutes is 1.5 minutes, which is 90 seconds. You multiply all those together and you'll get a value of 1620. Adding up these three values here, so 1755 plus 1440 plus 1620, they add up to 4,815 meters, which is the total distance traveled, and then you divide that by the total time taken for the whole journey. So like I mentioned, that's 4 minutes, but we have to convert that into seconds by multiplying by 60. 4 times 60 is 240, so you divide by 240, and you get a value of 20.1 meters per second. Does this exceed the speed limit? No, it doesn't, because it's less than 22, which is the speed limit. Let's now move on to this next part of the question. It's told you that the separation is dependent on the response time, the time taken to initiate a response, and that the government advises between 1.6 and 2 seconds. It's a suggested value d for when the speed limit is 31 meters per second. What it's asking for is what's the safe distance for the two cars to be apart if the maximum reaction time is 2 seconds. So again, we use the fact that distance is speed multiplied by time. We take the speed limit of 31 and we multiply by, so you can multiply by 1.6 or 2, but I'd advise 2 because that would lead you to the correct answer, because you want to be as safe as possible, if that makes sense. So you want to take into account the longest reaction time for the person. That will be 62, so the final answer is 62 meters. The two cars should be 62 meters apart at all times if they're traveling at the speed limit. Let's now move on to this next question. So it's given you, it's told you that from moving this constant speed limit, the brake force is now applied and it goes from 31 meters per second to rest. So straight off the bat, it looks like you will have to use CVAT equations because there's so many variables given. For example, the initial speed that it was traveling at is 31 and it's coming to rest, meaning the final velocity would be 0. It wants you to find the time taken, but with using the CVAT equations, you need 3 known variables and 1 unknown variable. So how do we find that third known variable? Because we only have 2 known variables. Well, it's giving you a mass and it's giving you the force that's applied, the braking force. Force and mass relate to force equals ma. You can divide both sides by mass to get the acceleration is the force acting, which we convert into newtons by multiplying it by 1,000, divided by the mass that it's acting on, 1,200. In your calculator, that'll get you a value of 5.7. So that's the acceleration for the whole journey. Minus 5.7, that is. But we can take it as 5.7. Oh, sorry, no, we want to take it as minus 5.7 because it's decelerating, isn't it? I don't know why I said positive. How do we find the time taken now? Well, the equation linking, I'm going to write this out clearer. The equation linking v, u, a, and t is v equals u plus at. Substituting the values into this equation, we get 0 is equal to 31 minus 5.7t. Add 5.7t to both sides, so 5.7t is equal to 31. And then divide both sides by 5.7. And that gives you that t is equal to 5.5 seconds. That's your final answer for the whole question. Actually, sorry, it's also asking for the distance traveled by the car. We can also find s using the variables u, v, and a. We can rearrange, or an even easier way actually, you can use s equals ut, so u multiplied by t, plus a half of at squared. Let's write out a half times the acceleration that we found before, minus 5.7 multiplied by the square of the time, 5.5 squared. All of that will equal 85 meters on your calculator. And so that's your final answer. Moving on now, we're going to have a look at this question that looks at a car moving in circular motion. It's giving you quite a bit of information. I'm just going to summarize it here. So we're going to write that the mass is 1200 kg. We're going to write that the radius is 200 meters and that it's sloped at an angle of 5 degrees, just like it's shown here. It's also told you the forces acting are the weight, which acts vertically downwards, the normal reaction force, which is always at 90 degrees to the surface, and yeah, that's pretty much it. It's a suggestion advisory appropriate speed. Okay, in this whole journey, what we've been taking is the fact that the resultant force is always 0. We've been taking it at every stage. That's what's allowed us to use distance equals speed times time, and we're going to carry on using that. The fact that the resultant force is 0 if it's moving at a constant circle. Otherwise, it wouldn't move at a constant speed in a circle. Let's break down all the forces acting. Pulling it inwards towards the center is the centripetal force. By the way, this is year 2 A-level physics, further mechanics. If you haven't done it yet, don't worry about it. You can skip the rest of the video. The normal reaction force, we can split this up and create its own triangle because we know this angle 5 degrees matches this angle here. 5 degrees. Now there's a little trick I like to use. The component that touches the angle is always cos. So we say this vertical component is n cos 5 degrees. Whereas the component that doesn't touch the angle is always sine. Oh, sorry. I just realized one thing. The centripetal force always acts towards the center. The center is to the right of the car because it's being pulled inwards towards the car. This is more like the edge of the motorway, if that makes sense. So if we were to draw the whole circle out, it would look something like that, and so the center would be around here. So the centripetal force would act towards there. Sorry about that. Just write that mv squared over r, and the component of the force n that acts to the left is the component that doesn't touch the angle, so that's going to be the sine component, so n sine 5 degrees. Like I mentioned, everything is moving in a constant speed, is in a constant circle, so the resultant force is 0, vertically and horizontally. Using the fact that it's 0 vertically, we can say that the vertical forces are balanced. We can say the weight is balanced by n cos 5 degrees. Using the fact that, so I'm just going to write here, we use the fact that resultant force equals 0 vertically here. It's a very difficult question actually. Using the fact that resultant force is also 0 horizontally, we can say that the force to the left, n sine 5 degrees, is balanced by the force on the right, which is mv squared over r. Resultant force equals 0 horizontally. And we can actually combine these two equations to make v the subject, and that will act as the velocity that is advised for this section of the motorway. So let's move on to that. We multiply both sides by r, so r n sine 5 degrees is equal to mv squared. Divide both sides by the mass. So, divide both sides by the mass. Square root both sides. So v is equal to the square root of all of this. Do we have all these values? So we have the mass, we have the radius, but we don't have the value of n, the normal reaction force. That's where we rearrange this equation here, and we say that, so I'm just going to change two things, the thickness of my pen and also the color of my pen, because it's just so it's clear for you guys. But we can make n the subject of this equation because we don't have it. We can say n is equal to w over cos 5 degrees. And we can say that v is just equal to the square root of r multiplied by this equation for n, w over cos 5, multiplied by sine 5, all over the mass. You can simplify this further, but just to make it easy for you guys, the weight is just mg. So you can just replace weight with mg. You can replace the mass with the value that's given, 1200 kilograms. You can replace g with 9.81. You can replace r, the radius, with the radius given as 200 meters. And once again, replace this mass with 1200. Put all of that into your calculator, and I'm just going to quickly do that for you guys. That will be equal to 13 meters per second. That's the advisory speed. Quite a difficult question there, and this whole question here is quite labor intensive. If you have any questions with it, just let me know. Otherwise, thanks for watching and have a nice rest of your day.